Okay, so let's solve this problem. So to find the solution of these rational inequalities, so first, we need to equate this equation to 0. So transpose this 1 over x plus 1. So this becomes 4 over 2x minus 1. Since positive becomes negative, 1 over x plus 1, then greater than or equal to 0. Then simplify, so using the butterfly method, so multiply this 4 and x plus 1. So 4 times x plus 1, then minus this 2x minus 1 times 1, so 1 times 2x minus 1, then over the product of these two denominators. So 2x minus 1 times x plus 1, then greater than or equal to 0. Then simplify, so this 4 times x, that's 4x, and 4 times 1, that's positive 4. Then negative 1 times 2x, that's negative 2x. And negative 1 times negative 1, that's positive 1, then over. So for this denominator, so just copy. So we have 2x minus 1 times x plus 1, then greater than or equal to 0. Then simplify the numerator by combining like terms. So this 4x minus 2x, 4 minus 2, that's positive 2x, and positive 4 plus 1, that's positive 5, then over 2x minus 1 times x plus 1, then greater than or equal to 0. So this time, to find out the critical values, just equate the numerator and denominator to 0. So from the numerator, so that's 2x plus 5 equals 0. Then we have 2x equals transpose, that's negative 5. And divide both sides by 2, so x is equal to negative 5 over 2. Then from the denominator, that's 2x minus 1 equals 0. So we have now 2x equals transpose, that's positive 1, then divide both sides by 2. So x is equal to positive 1 over 2. Then the last one, this x plus 1 equals 0. So x equals transpose, that's negative 1. So these are the three critical values. Then put these critical values in a number line. So this one is 0. We have negative infinity and positive infinity. So for x equals negative 5 over 2, so the same as negative 2 and 1 half. So in a number line, this one is negative 1, negative 2, and negative 3. So for this negative 2 and 1 half, so this point, that's negative 2 and 1 half, or negative 5 over 2. Then for this x equals positive 1 half, so this is positive 1, so this point is positive 1 half. Then for x equals negative 1, so this is negative 1. So these are the critical values. Then to find a numbers to test, so we're going to use this method, the before, between, and after. So for before this first critical value, so this number, that's negative 3. Then between, so between these two critical values, so this number, that's negative 2. And also between these two critical values, so this number, that's 0. Then the last one, the after. So after the last critical value, so this number, that's 1. So these are the numbers we need to test. Then put these values in a sign analysis table. So we have x and values for x. So start with -3. Then this -5/2. Then this -2, -1, 0, +1/2, and the last one is +1. Then for the numerator, so for the numerator, that's 2x plus 5. And for the denominator, so we have this 2x minus 1 and x plus 1. Then the last one is the result. So this time starts with the critical values. So this -5/2, -1, and +1/2. So these are the critical values. So if x is equal to -5/2, this equation becomes 0. And if the numerator is equal to 0, then the result is 0. Then for x equals -1, this equation becomes 0. And if the denominator is equal to 0, then this equation becomes undefined or error. Then if x is equal to +1/2, so this equation becomes 0, and 0 denominator, that's error or undefined. Then from the test of numbers, so if x equals -3, so if x is -3, so 2 times -3, that's -6. And -6 plus 5, that's -1. So therefore, this one is negative. Then for this equation, so if x is -3, so 2 times -3, that's -6. And -6 minus 1, that's -7. So this one is negative. Then from this equation, so x is -3, so -3 plus 1, that's -2. So this one is negative. Then negative times negative, that's positive. Then for the result, so negative divide by positive, so dividing, not the same sign, the result is negative. Then for x equals -2, so 2 times -2, that's -4. And -4 plus 5, that's +1. So this one is positive. Then for x is -2, so 2 times -2, that's -4. And -4 minus 1, that's -3. Then for this equation, so x is -2, -2 plus 1, that's -1. And negative times negative, that's positive. Then divide, so positive divide by positive, so the same sign, the result is positive. Then for x equals 0, so if x is 0, this one is +5, so positive. Then for x is 0, so this becomes -1, so this one is negative. And for x is 0, so this becomes +1, so that's positive. And negative times positive, this one is negative. Then divide, positive divide by negative, so not the same sign, that's negative. Then the last one for x equals +1, so 2 times 1, that's 2, plus 5, that's +7. And if x is positive 1, so 2 times 1, that's 2. 2 minus 1, that's positive 1. Then 1 plus 1, that's positive 2. And positive times positive, this one is positive. Then positive divide by positive, so the result is positive. So this time to find out the solution, since the condition is greater than or equal to 0, and again, all positive numbers are greater than or equal to 0. So therefore, from the result, just look for the positive. So since we have this positive between this negative 5 over 2 and negative 1, so this negative 5 over 2 and negative 1, and also this positive to the left of positive 1 half, so to the left of positive 1 half. But since we have this equal to 0, so therefore if equal to 0, that value is part of the solution. Since for negative 5 over 2, the result is 0, so therefore this 5 over 2 becomes square bracket. So to write now in notation form for the solution of this rational inequality, so we have square bracket, then negative 5 over 2 to negative 1, parenthesis, then union, this positive 1 half, so parenthesis, to positive infinity. So this is now the solution of this rational inequality.